Now let me give you a glimpse of how the hexadecimal system is actually. So we are talking about the hexadecimal right now. If we take, let's imagine, here is our imagination engineer, always imagine that what it's going to be. If you truly want to be an engineer, you have to be like me, okay? You have to think. Well, okay, okay, that's enough. Let me correct it. I made it, I've tried it good way, but it got a bit tilted. Okay, now we're good to go with. Okay, now if we have 4-bit, let's say here is our 4-byte, not bit, 4-byte. So 4-byte means each byte is having the possibility of 16 per byte. If you want to recall that, we can remember it here, that we are having 4-bit, and in 4-bit we are having 2 possible combination of the zeros and ones. So we are actually having 2 to the power 4, which is actually 16. Okay, now get back to this one. So if we are having 4-byte, if we use the decimal number system, what it actually can be, there are 10 possibilities, 10, 10, 10, 10. What are the 10 numbers? 10 numbers are 0, 1, 2, 3, up to 9. So these are the 10 numbers, including the 0. You can count it down, and this is going to be 10. So 10 to the power 4, which means 10,000. But when scientists looked at this carefully, they thought that there's something wrong here. What's wrong here? The thing which is wrong is actually it's the inefficient way of using the storage system. It is making the system slower. So they created another number system that is called the hexadecimal number system, which is starting from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, and these are the 16 numbers. So it can possibly have 16 possible combinations. So let's see the difference. So now it is having 16 possible combinations, 16, 16, and 16. So 16 to the power 4 is actually 65,536. Now this is the massive difference. We are ignoring 55,536 possible combination with the same space that we are using. The space in terms of the bits and bytes is actually physically getting stored in our system if we use the decimal number system. And this is the most efficient system. You cannot have the 17 possible values because bit makes byte, and we are working, the entire system is working on the binary basis, so we can only have possibility of 0 and 1 unless we talk about the quantum computer. That is not here in our world right now, right? So this is the massive difference that creates the massive data difference in the same storage space. It increased the speed. I would say it boosted the speed. So that's why it is important. If you have not got this idea completely, that's completely fine. I gave you a glimpse about that, and we're going to study its detailed explanation and whys and hows and all the kind of things when we study the digital electronics. As you notice that I am saying again and again, we will study this in digital electronics, we will study that in computer architecture, we will study that in the hardware section. That is because it all is interrelated, as I told you again and again. But for the sparking curiosity, but to make a good foundation, you should know this all the things so that you can keep that in mind, and when you learn that, you actually discover or rediscover, I could say, the concept and truly understand its importance. So I'm bringing up the questions more than the answers in these classes. So my super engineer, we have completed the data representation. Congratulations. And now we are on our network. So let me ask you a question. When I say network, what comes to your mind? I'm ending this lesson right here and giving you some time to think. Till the time the next video, we are going to meet and see that what are the networks. Take care, God bless, and stay curious.